going to continue about the pressure. The pressure. But here, the pressure that we are going to talk is the pressure in a liquid. So, in a liquid. Right. So, as you remember that the liquid is the particle that can fit with its container. It means the liquid is one of the fluid. Is one of the fluid. Another fluid is a gas. So the difference between the gas and liquid, the liquid cannot be compressed. It cannot be compressed. So when you have a syringe here with the open endpoint, and it has a piston. Okay, so this one is called as a piston. And if you fill this with water, maybe you cannot push the syringe if you close this opening. But when you add this with air, maybe you can compress it. You can move it a little bit because the air can be compressed, and the particle of the air will be moved faster. And in this condition, the air pressure inside the syringe is higher than outside of the syringe, right? So we go back to the liquid. So the liquid can be compressed. When you press a liquid in a channel or in a pipe, the liquid will move to another area, to another point of the pipe. Here I have a U pipe that has two different openings. Okay, so okay, it's small, I think. Okay, a U pipe with different endpoint. The first opening is smaller than the second opening, like this. Okay, and I fill it with water. Fill it with water so it has the same level of the water. Okay, the water is blue, I think. Yeah, like this. And then I put the piston. The piston, like the pushing thing in the syringe. There's a piston, and it also has a piston. Okay, so let's say the opening of this is the opening A, or opening 1, and this one is opening 2. Alright, so there's another example, another situation. If I push this piston downside, so the water level of this will increase, and the water level in the opening 2 will be increased. Right? So the water moves to this opening, and this is the pressure in the liquid, right? And the pressure of each side, it should be in balance. The amount of pressure both sides. So if you give a pressure here, it's P1, and it has a same pressure here, so P2. So pressure 1 should be equal with pressure 2. So you know that pressure is a force divided by area. So force 1, area 1, it means this part, okay? And pressure 2 is a force 2, and area 2. So this formula can be used to find the force in A, in 1, or in 2. For example, if if I put a car here, sorry, I put a ball, a solid ball made up of a metal, and this ball has the mass of 20 kilograms. Okay, and then the area of this piston is 10 meters square. Okay, okay. Why is not the area that ball touched to the piston? Because the pressure comes from this liquid. So the area that we concern is the area of this piston, not between the ball and the piston, but the water and the piston. Alright? Okay. The ball is 20 kilograms and the area is 10 meters square, while this area is only 2 meters square. So the question is, how much force must be applied to piston 1, so 20 kilograms of metal ball could elevate. Right, so how much the pressure that you give to this piston, in order to make these balls elevate. Right, so you can say that the force of this area is transferred to this area. Okay, now we find the force of this P1. Okay, so you have a data here. The mass of the ball is 20 kilograms. It means 20 kilograms. It also means that the force of this ball is 200 Newton. Okay, because it times gravity. And we know that the area of the opening 2 is 20 meters square. Okay, while in area 1, the force is the thing that we are going to find, while the area is 2 meters square. So you may substitute this formula into this case. Okay, so F1 per A1 equals to F2 per A2. F1, we don't know F1, so F1, and then the A1 is 2 meters square, and F2 is 200 Newton. Okay, so alright, 200 Newton. Okay, it's 2 meters square, and then the area is 10 meters square, right? So we move to this. Okay, go to this. So I write here F1 per 2 equals to 200 per 10. And what to do is, it will move here, so you times the cross multiplication is 2 times 200 and 110 times F1. So 10 F1 is equals to 400. So F1 is 400 divided by 10, so it's 40 Newton, right? So the force that should apply to this opening is 40 Newton to elevate the ball that has a mass of 20 kilograms. Or you can say you have to apply 40 Newton to this opening to elevate the ball that has a force of 200 kilograms. So it's you only may you only may exert the force, the 40 Newton force, to elevate the 200 Newton force by this hydraulic pressure. Hydraulic pressure. So that's all.